Hello everyone. My name is Karel Zikmund and I would like to talk today about networking in .NET 7. What's new, what we added, and what you might be interested in using in your daily lives as developers. So let's get started. What I want to cover today, I want to cover HTTP free and QUIC, evolution of HTTP protocols, when and why you might want to use the free version, how to use it, and obviously plans forward. Similar thing about HTTP 2 WebSockets, what's different of the HTTP 1.1 WebSockets classic one and how you use it. And then touch a little bit on YARP, even though it's not brand new. It actually fits into this overall picture, and that's something that you might want to kind of look into. I'm going to talk about what is YARP and what is a reverse proxy in general, why would you want to use reverse proxies, and as well how YARP is used in production in pretty cool scenarios. So let's get started. First of all, HTTP. So a little bit of history. I assume that everyone knows HTTP 1.1, that you have seen it before. You might not be that much familiar with HTTP 2, and later on I'm going to explain HTTP 3 as well. So HTTP 1.1 is a textual protocol. So you can look everything in your text editor at everything. You have for example, headers. You have header name, colon, and then value. It can be keep alive or whatever interesting header names are there. However, in HTTP 2 is a binary protocol, which means there are frames. Each frame says like, hey, I'm this big and this data is in there, some kind of headers, these type of things. And the headers, for example, are stored via HPAG, which some of them are in textual form, but some of them, the commonly used, are actually compressed into indexes. So you can say like, hey, I am header number 5. And obviously that's not that much readable because you would have to know what exactly header number 5 is, which can be dynamically determined during the connection. Both of the protocols work on HTTP and HTTPS, which means encrypted and non-encrypted. Even though with HTTP 2, the unencrypted is not that allowed, and many people actually don't know that it's possible at all. With HTTP 1.1, typically you have one connection where you can send only one request. We have to wait for the request to come back before you can send another request. To have multiple requests at the same time, parallelism, you have to create multiple connections. What does it mean? It means that you have to create multiple TCP connections. Each TCP connection has a slow startup. There's some kind of TCP window ramp up, and that takes time. On the other hand, HTTP 2 is basically one TCP connection that knows how to multiplex. So you establish the connection once, and then you can use multiple streams. By default, 100 can be higher, based if the kind of server and client agree on that. And you can basically multiplex different streams, which means different requests over the same connection. Once you run out of the 100, you have to do more things, but in parallel, as soon as you finish the request, you can send later another one as well over the same connection. The other thing, not only the TCP kind of slow start is kind of one thing that is not quite so good about HTTP. In general, there's another thing that kind of is a little bit in the way and matters, and that's the handshake. So it takes time for the TLS to basically being established, and as well for the TCP handshake to kind of happen. Now, by default, it's freeway handshake. So free RTTs, free round trip times back and forth between you and the other side. With TLS 1.3, that was brought down to two-way. So if you're using TLS 1.3, you already get kind of a little bit faster start, which is good. Now, why RTT matters? If you're on local network, probably doesn't. In the same data center, probably doesn't. However, as soon as something significant, for example, between data centers, or imagine some remote clients, imagine, for example, LA time to Sydney or London to Sydney, that distance, even because of this, if you go by speed of light, you cannot make the round trip faster than 160 milliseconds. If you need 3 of them, there you go, half a second, just to establish a connection, and not even that. And that's theoretical speed. It's going to be probably a bit larger in practice because there's some kind of overhead here and there. Another interesting thing on both protocols, or which try to speed up or some problems, is on HTTP 1.1 there's HTTP pipelining. What does it mean? As I described, on HTTP 1.1, you send request and wait for the response. Pipelining basically says you can send requests, and you're gonna get even before receiving the responses, and you're gonna get responses in the same order. So you send request number 1, number 2, number 3, and then you start receiving response number 1, number 2, number 3. It has troubles in implementations, and actually many protocols, many kind of runtimes don't support that. .NET Framework and .NET Core, neither of those actually support pipelining from kind of security reasons. HTTP2, doesn't have this problem because you have already multiplexing, so that's you don't need something like pipelining over there. It's basically by design. However, it has trouble with the head of the line blocking. What is that head of the line blocking? It basically means that if you lose a packet because you're over TCP connection, that packet has to be retrieved, and TCP guarantees order of delivery, which means that all the remaining packets are blocked in processing until you retrieve that packet. So our round trip time there and back, which again, big distances might matter quite a bit. All the streams are blocked, even though the packet had maybe for data from 1 or 2 streams only. All the other parallel streams that are in theory unaffected will be blocked because TCP is the underlying protocol. So how does it look with HTTP3? I just brought in the HTTP3 description, and let's compare it to HTTP2. Both are binary protocols, some framing and stuff very similar. HPAC is replaced with QPAC, which is, in principle, very similar kind of specifications. HTTP3 is only HTTPS only. So it doesn't allow the unencrypted version, and we're going to get to the why. Because instead of TCP connection, actually it uses QUIC connection. What's a QUIC? QUIC is UDP plus TLS 1.3. So those two may be even higher in the future. But basically UDP and TLS all together. That replaces the transport, which is TCP in HTTP2. It has as well ability to do concurrent streams as HTTP2, multiplexing, again, by default, 100 concurrent streams. Client server can agree to have it higher. Now, the good properties, because the UDP is kind of, together with the TLS 1.3, is that you can have only one-way handshake. So you wait one round trip time there and back to establish the connection. That's obviously much better. Fairly compared, it's to the two-way handshake with the TLS 1.3, because by design, HTTP3 or QUIC uses TLS 1.3. You can have actually option of zero-way handshake, zero RTT. For that, you need to have keys from previous sessions stored with the other side. However, it's dangerous because it's susceptible to replay attacks. Somebody can capture your traffic, and even though they don't know what's inside, they can replay it later. So if you would send something like, hey, transfer this amount of money to that account, somebody replays that, you probably don't want to do that. So the zero-way handshake basically is limited, that you should use it only for idempotent requests, some kind of harmless GET requests that don't have side effects. Because nobody can, in theory, or nobody should be able to decrypt the traffic, but they can replay it. Zero-way handshake is not in .NET 7 yet, 7.0 yet. It's going to be something we're going to look in future. Now, the great value is that we don't have the head of the line blocking over here in HTTP3. The reason is that it's built on UDP. So if you lose a packet, unlike in TCP, when you have to block everything, you're going to block only the streams that contain some data in that packet. So if the packet was lucky to get like 2 or 3 streams, those will be blocked. All the other streams still continue because UDP kind of doesn't require to processing further packets before you retrieve the lost one. So what other advantages we can see in HTTP3? First of all, when and why would you use it? Unreliable networks, that's where it works great. It's typically the last mile, so kind of down to your device or to your machine. As I mentioned, it doesn't have the head of the line blocking, and on top of that is actually improved loss recovery. So even compared to TCP, there have been improvements in that. Other things you might use it in mobile scenarios is for transfer between networks. So it's capable basically if let's say you're on your Wi-Fi, with your phone, you work a little bit further out, just transfer to LTE. In HTTP2 and HTTP 1.1, the connection is basically broken. Now HTTP3 uses connection IDs. I think it's actually maybe even in the QUIC protocol, the connection IDs, and it's smoothly transferred to the other network. So you basically, as a developer, you don't know that something like that happened unless you want to. It requires server support. The good news is .NET server and client both supported by default, so you don't have to do anything to get that. So where is HTTP3 supported? How common it is. First of all, quite a lot of websites, quarter of websites already support that on the internet, so that's good. Major CDNs, awesome. Major browsers, if you look at that, Chrome, Edge, Firefox, Opera, like all have it. Safari is a little bit behind, but you can see the green thingy, so they're kind of working on that. It's, I think, installed preview or something like that, so it's coming. But most of the major browsers already support it today, so you can jump on that and use it. Some drawbacks or some things that are not so good. You should be aware that's not all network appliances like reverse proxies or maybe kind of some routers, and these things support all UDP, which means therefore HTTP3 and QUIC. So before you do that, like I would recommend you to kind of check out, especially in your cloud providers and whatnot, this in the solution that it is something that's gonna work. Everyone sees that it's coming, so like the features are bringing up, but if you do it today, you might not be able to kind of run it smoothly. Now, another thing, like where you should not use HTTP3, like in theory you can use it anywhere, but when it doesn't make sense is, for example, server to server, in the same data center. If you do that, you have like low latency, probably not really lossy network. At that moment, you don't get much value really from using HTTP3. However, if you upgrade just between data centers, already kind of you getting some values. So data center to data center, bigger distances, that's where it makes sense, even on the kind of backend. Let's look at the QUIC protocol. So far, we have been talking about the higher up HTTP3, which is built on top of that. So as I mentioned, this is transport protocol, basically, in the HTTP3 replacing the TCP, or in the HTTP replacing the TCP, so UDP plus TLS 1.3. It's unreliable delivery. It has like as a feature that's not bubbled into HTTP3. Imagine for streaming scenarios, you stream video, like something is lost, you don't want to kind of retrieve that and whatnot, to just like, deal with that, this lossy stuff, or audio video calls and that stuff. That's not supported in .NET yet, something you're gonna look into in future. Other thing is actually multipath. That's a feature that allows you to use multiple network routes to the same endpoint. That's still in our, RFC is in progress. You can either duplicate the traffic, which means that you get like lower latency, whichever packet or whichever data gets there to the end wins. That's streaming, or you can actually use it to increase your bandwidth. So you send half of the or some amount of data on one connection and on the other one, or route, rather network route, if you have like two network cards or something like that, two different networks. Overall, QUIC is extendable and versioned, so you can expect more features in the space in future. So how would you use HTTP3 and QUIC in .NET 7? First of all, or not how would you use it, what you can use. First of all, HTTP3 and QUIC, HTTP3 is MS QUIC based. It's a Microsoft open source project, cross-platform. You can jump, contribute, look at it, view the code, whatever you want to do with that. HTTP3 in .NET 7 is general availability quality, GA quality, of both client and server on Windows and Linux. Our performance is actually pretty good. We're roughly on par with HTTP2. Some scenarios a little bit faster, some scenarios a little bit slower. You should expect more work in that, and we hope that in .NET 8.0 we're going to be able to say that we're better or than HTTP2 almost all, if not all, at least majority or most of the scenarios. Now the QUIC APIs are a little bit tricky. They are general availability as well, fully supported, but only from functional stress and kind of like functionality perspective. The API shape itself is still marked preview, and that's because we didn't get really great validation from customers. That's something we're looking for. So we reserve the right to change and adjust the API in .NET 8.0. You should not expect major changes, but like, final touches here and there. So you can view this, like you can use it, it's supported. So if you find a bug and it's important, we're gonna fix it in service sync and whatnot. But if you write an application on top of QUIC APIs, and then you want to migrate to .NET 8.0, you need to be prepared that you might be forced to make some small changes, catch different exception or something like that. We're going to document obviously the changes for .NET 8 so that it's easier for developers. We'll use it as well, like a shout out if you're interested in HTTP3 or QUIC, please use it. If you want to help us validate the APIs, let us know on GitHub or ping directly me on Twitter, anywhere. And the same holds if you want to help us tweak performance in some interesting scenarios. If you have some data, if you're looking into that, please talk with us. We're going to be more than happy to work directly with you. So how do you use HTTP3 in .NET? An HTTP client, the client side, that by default defaults to HTTP 1.1. It doesn't even default to HTTP 2. It's probably never going to change that. The reason is that when we did that in the past, it actually broke customers because they were not ready and whatnot. So that's stuck in there. So if you want to use HTTP 2 today, you have to set the HTTP request message version to version 2.0. With 3.0, you use version 3.0. That's going to get you to HTTP3. So fairly simple, fairly straightforward, similar usage as HTTP2. On the Kestrel side, on the server, that defaults to HTTP 1.1, HTTP 2. So when you build a Kestrel, put it in deployment, by default, it's gonna support those two protocols. You can change that via listen options protocols. I've showed you some code over here on the right side, where the first part or the first third first part is HTTP 1 and HTTP 2, which is the default. You can add HTTP 1, HTTP 2, and HTTP 3, or you can say like only HTTP 3 or only HTTP 1, whatever combination you want in there. Let's move on. How would you use QUIC APIs? So first of all, reminder, the API is still preview. We reserve the right to kind of change the API in .NET 8.0, but it's fully supported and it's GA quality from functionality, stress, and other point of view. You have to opt in to use that. You have to use the preview features. Here's an example how to do that in your project file. Fairly simple. You just set one boolean to true. So what's going to happen in the space in future? HTTP3 will be enabled by default in Kestrel, which, by the way, already happened in 8.0. James Newton King made it happen. I think it was early in October, so more than a month ago. You should expect more performance work, as I mentioned. We will finalize the QUIC API shape. Zero RTT I mentioned earlier. We're going to do opt-in features. You should expect that we're going to support more operating system like macOS, mobile platforms. And on top of that, there are going to be additional features and extensions, right? Yeah, I already talked about the multipath, but there's, for example, gRPC over HTTP3, which, again, James Newton King, who works on the gRPC in .NET, he actually used our implementations to write the RFCs, and the RFC, if you look at the RFC in gRPC over HTTP3, that's actually coming from our site and experiments on our implementations. Web transport over HTTP3, another interesting protocol. It's basically WebSockets done right. I'm going to talk about it a little bit later. QUIC datagram, another emerging protocol that we're going to probably support very soon. So let's move to the very next topic, which is HTTP2 WebSockets. That's new in .NET 7. By the way, the protocol itself is same as the HTTP 1.1 WebSockets, so nothing much changed. It's just over HTTP2 connection. I will describe the differences between the connections, HTTP connections themselves. So what's the advantage? Why would you need to do that? The interesting part, the value that HTTP2 brings as well to WebSockets is actually that you can reuse the same connection for multiple requests and that stuff. So you can have multiple WebSockets connections, or you can have like normal requests as well combined with WebSockets connection, all on the same TCP connection. So you get better perf, especially on establishing the connection. If you look at the Chrome and Edge, it's enabled there by default, so it already kind of works. On the SignalR server, it's enabled now by default, and SignalR clients in .NET and JavaScript as well support that. How would you use it on client? So using our client WebSocket APIs, it's slightly different than the traditional HTTP 1.1 WebSockets, and that's because you need to pass us the HTTP client or the handler, HTTP client handler, which in this case is Sockets HTTP handler. The reason is that for the HTTP 2 WebSockets to be really useful and better perf, we need to share connection. We don't want to pool the connections for you. We did it in the past, especially in .NET Framework at Service Point and HTTP request, and that really didn't go well. It caused lots of troubles. That's why we have the HTTP client model, which is really, there's a one client, and that's how you say what's kind of used, what's pooled, and whatnot. So the same over here, we basically require you to tell us on which connection we should use. You can share it statically across the all application. You can have it per component or per whatever you decide. It's really up to you. And you just pass the HTTP version to version 2.0 or 2.0. You can as well say like, hey, I want this version or higher. By default, it's version or lower, so it's going to downgrade to 1.1. If you try to kind of establish the 2.0 without passing us the HTTP client handler, we're going to throw. So we're going to basically tell you like, hey, you're trying the version 2.0, but you're not reaping any of the benefits. So please don't do that. Anyway, that should wrap it up. And let's actually look how it looks like on the server. So on the server, it uses the connect word instead of get word. So you may need to update your routes. Here's an example. Instead of the HTTP get, you have to use as well the HTTP connect attribute. Now that attribute is not part of .NET 7. It's going to be part of .NET 8. However, it's super simple. 5 lines of code or 3 lines of real code, 2 curly braces. You copy paste that into your code, your application, voila, you can get it going. So very simple. What's future of WebSockets? First of all, the HTTP3 WebSockets, which is going to be, just recently published RFC, very similar to HTTP up to upgrade. It's just like different underlying HTTP3 version. That's all. And the web transport, which I mentioned over HTTP3, which is WebSockets done right. What's done right on that? That first of all, the web transport itself allows you to create multiple streams, so it's multiplexing on its own, and on top of that you can have multiple sessions, the web transport sessions in the same HTTP3 connection. So you can have different components talking to the same server over the same HTTP3 connection. We have experimental Kestrel support. There was a blog post recently, end of September, so check it out. And HTTP client, we actually have a prototype, so we know that it's going to come very soon. Let's move to the next big topic, which is YARP, reverse proxy. So yet another reverse proxy. It's open source. You can see, check it out, Microsoft/reverse proxy. It's layer 7 proxy, which means terminates requests and then issues them further. And you might have heard about other popular reverse proxies like Nginx, HA proxy, Envoy, Ocelot. Now, why YARP? First of all, YARP is developer first, reverse proxy. So which means that we are a library, we're not executable like many of the others. We are really designed for extensibility in C#. We are layered, so you can replace almost any part, and it's really good for that. So you don't have to use any Lua or C++ extensibility and that stuff. It's cross-platform, obviously. It has great perf if you compare it actually with the others, and we, by design, get from the .NET platform the latest protocols like gRPC, HTTP3. You don't need to wait for that to be implemented specifically for the reverse proxy. The HTTP2 WebSockets is another protocol that's going to light up. It requires actually a small tweak in the YARP itself, but it's very small. It's going to come in the next version of YARP. On top of that, we're using actually YARP to drive innovation and perf improvements into the .NET platform itself, because it's a great end-to-end scenario. It's used with not high-profile cases, but in high-scale cases, high-performance places, and we kind of work with the customers and try to kind of get it even faster and faster. So what is a reverse proxy? If you're not familiar with that, on one side, on the left side, you have public internet, then you have the reverse proxy, and then you have your endpoint. So the reverse proxy basically serves as a public endpoint for your service. You have multiple servers, multiple services, or one service with multiple servers. You can load balance between them. You can offload work. You can do lots of interesting things. We're going to look actually what else could you use them for. So the classic load balancing I mentioned, you can do A/B testing. You can do version rollout, slow version rollout, see if nothing breaks. Health checks, interaction between the URL space and backend. You can actually, present, consistent API surface in the reverse proxy, no matter how the implementation on the servers. You can offload some stuff. So those are the kind of boring, normal reverse proxies scenarios. The interesting scenarios like authentication migration. We have seen customers actually who had, wanted to migrate to new authentication, or they had multiple services with different authentication. They put reverse proxy in front of that, created another, use the correct authentication, and then kind of translate it and could slowly upgrade the services themselves. You can create cloud, tunnel from cloud to on-prem, which is actually sometimes super useful. It's 100 lines of code, but otherwise, actually pretty working. It should be much simpler in the next version of YARP. You can route local traffic to remote servers, so single point of control and config serves like, basically like a forward proxy. It's actually ingress for Kubernetes or Service Fabric in general, not only YARP, but general reverse proxies. And there's actually special talk about like how you can use YARP for .NET Framework migration to .NET Core. I'm not going to talk much about that. So what does it mean in production? If you look at the blog post from Upservice, actually they have like from amazing, worldwide traffic, like 2 million RPS. They got lots of benefits, like lower CPU usage, like great performance improvements. They actually united their like Windows and Linux implementation, which was Nginx as well, and they got latest protocols like gRPC, HTTP3. Lots of goodness. Dynamics is another service, large service that actually uses that. They have like pretty impressive traffic as well. Obviously, if you compare it to Upservice, it's a little bit smaller, or not obviously, but at least it is. So how would you get started? It's actually super simple. It's 5 lines of code. You kind of get the YARP, the NuGet package, and you do these, you create builder, you kind of load the config, build, map reverse proxy, run, and you're done. Then you have some stuff, obviously, in the configuration, like what goes where and that stuff. We have good, documentation, so check it out if you want to. It should be super simple. And with that, we are really out of time. Last minute, what we talked about today, HTTP3 and QUIC, support in 7.0, GA quality. So QUIC API's shape is still is going to change in 8.0, but it's a great thing to do. Unreliable networks and mobile scenarios where it pays off. HTTP2 WebSockets, you need to do some changes in the code to kind of use that. And YARP is a library extensible via C#. So if you need to use reverse proxy, hopefully you're going to pick up YARP. Thank you very much for spending the time with me, and have a good day. Thanks for listening. Bye.